Hello guys, what's up? This is Murtaza. Welcome back to A Coder's Journey. In this next episode of my solid series in C#, I am going to teach you all about LSP or Liskov Substitution Principle. This is probably going to take a couple of episodes from this playlist because it is a little bit involved as compared with other principles. So I am going to take you through the different ideas of LSP step by step so that you guys can get a good grasp of the concept. As I told you, LSP I think is a little bit not difficult, but it has a broader kind of influence, and it is somehow a little bit maybe challenging to understand when compared to the previous concept. So please stick with me till the very end. In this episode I'm gonna cover a good portion of this principle, and over the next couple of episodes we are going to go over the other rules or the other sides of this principle. So according, and by the way, you know that we first go over the topic theoretically, right? We talk about the ideas, and then in the next video we're gonna go over the code, and I'm gonna show you exactly how you can implement this and how you can apply it to your code base. So first let's see how what this LSP is all about. So according to Robert C. Martin or Uncle Bob, the LSP or Liskov Substitution Principle states that functions that use pointers or references to base classes. So suppose you've got a method or function that takes in as a parameter, takes in a type, right? Or an object of a type from C#, right? In C#. So functions that use pointers or objects, references, right? To a base class, right? So must be able to use objects of derived classes without knowing it. So for example, if I have a method which takes in a reference of a type called food, right? This method should be able to work when called with a reference of a subtype of food, which is, for example, meat, right? So this is the first idea of LSP. The function, the method, shouldn't be aware of the fact that you are actually passing in a subtype, right? A reference to a subclass, not the base class. For languages such as C#, this can be changed to code that uses a base class, right? A method that uses a base class as an input must be able to substitute a subclass without knowing it. So if your method is working, right, with an object of type food, this method should also be able to work seamlessly when passed in a reference of a subtype or a subclass like meat. Now, the LSP applies to inheritance hierarchies. Exactly. That makes sense because we are talking about base classes and derived classes, right? So these are all inheritance. It specifies that you should design your classes so that client dependencies can be substituted with subclasses. So these are the dependencies, right? They should be able to be substituted with subclasses without the client knowing about the change. All subclasses must, therefore, operate the same manner as their base class. So the meat, which is a subclass of food, should operate in the same way as the parent class or the food, right? The specific functionality of the subclass may be different, of course. So in meat, we might implement a method in a different way. So the specific functionality of the subclass may be different, but must conform to the expected behavior of the base class, right? To be a true behavioral type or subtype, the subclass must not only implement the base class's method, so the base classes of the food type, not only those base methods need to be implemented in the subclass meat, right? But also conform to its implied behavior. We will talk about this as we go along. This requires compliance with several rules. There are several rules when we are talking about LSP. You see, I have, put in these different rules as separate paragraphs. And in this video, I think I will go over the first rule, right? And then over the next few episodes, we are going to talk about the other rules, right? And then surely we will implement this LSP in C#. So the first rule is that there should be contravariance between parameters of the base classes methods. So this is a method in a base class, and this class is the subclass of animal. So there should be contravariance between the parameters of the base classes methods and the matching parameters in subclasses. This is the matching parameter. So basically, there must be contravariance between these two parameters, meat and food. So what does it mean? What does this mean to, we should have contravariance between the parameters of the methods from the base class and the corresponding method in the subclass. So this means that the parameters in the subclass, in this case meat, must either be the same type as those in the base class. So this parameter must either be of type food, which in this case isn't, or must be less restrictive. Restrictive. If you take a look at this example, meat is inheriting from the food class, right? So it is less restrictive. Similarly, there must be covariance. So contravariance between the parameters of the methods from the base class and their corresponding counterparts, in the subclass, and covariance between the method return values, so the return types, in the base class and its subclasses. This specifies that the subclasses return type must be the same as or more restrictive than the base class's return type. Look at this example. Here, the base class, the subclass. The base class is shape, the subclass is circle. Another subclass, square. Now, let's take a look at the return values of the methods. We have the method draw. Here, the return type is object. Here, the return type is circle. And circle, of course, inherits from shape, and it is implicitly inheriting from object. So here we have object as the return type and circle as the return type. Let's go over the rule one more time. There must be covariance between the return types of the methods in the base class and the subclasses. So here again, object and circle. So covariance means that the return type of the subclass must be the same. So this must either be object, which in this case isn't. So must be either the same type